To be live now. Let's see. Well, live, not like alive. Well, even though I am alive, but yes, assembly language. We were doing good yesterday, I guess. 150. And yep, we were ahead. We had we completed all these exercises? No, we had to do them. Okay, where were we? Yep, we had to do question number. Yes, we did this. Did we? Yep, we did. We did. We did this part. And we only used about 6 comparisons, and yep, and then we did this, and we didn't use any branching. We only used the branching to first call our function and then return to from where it was called. That is the all the branching that we used for this, and that is cool. Now question number this 10th. Write an AArch64 assembly function to calculate the average of an array of integers given a pointer to the array and the number of items in the array. Okay, your assembly function must implement the following C function prototype. Int average, this. Okay, and one more thing. The video that I uploaded yesterday has no voice in the like later 1/5 part of the video, and that is embarrassing. That and I noticed it like at the end, and when I noticed that, then I ended my recording, and here we are today. So I apologize for that. My OBS did something bad to me. I don't know why that happened. I guess it was a recording and that caused something. I don't know. Now here we are. Oh, oh, ah, shit. My mouse is not. It is working. It is not. Yeah, it is. Es funktioniert nicht. Aber es jetzt funktioniert. And no. Oh, I deleted that. Uh, so my code will come here, and that is above the function prototype that I want to make. And first I will get an array which will store numbers. What will be the size of the numbers? 32. Yep, 32 bits, and the numbers would be these. Is that a 32-bit number? Yep. Hey, wait. You can like be angry. I wrote this much yesterday, so array. Ah shit, I wrote quite a bit yesterday, and after that I noticed that my voice was not being recorded. So what did I wrote here? First here a string to print the average, which I will pass on to the printf function, and here the array itself on which I have to calculate the average. And since I'm stupid, I wrote 2 commas here, and then the length of the array is here, which is current minus the address of the first element in the array. That gives us the length of the array, but this gives us the length in bytes, but we are using 4 bytes to store a single element, so we can divide the length by 4 to get the actual length. So in the zeroth register we have the array, array is pointed to the array, the first element of the array, and in the first register, I will have the length, which will be for that I have to get the page address for length and add to it the offset for length page of. Now I have everything. I think I have whatever I need in life. No, I have to divide and save to the first register, divide by 4 to get the actual length. Yes, to get the actual length, because I get in wait. Till this command, I only got the address of length. And now I would like to store the load the value that is at that address, which is the actual length. So, which is load into register first, whatever is the value whose address is at register first, and then divide that value by 4, because that now and after this instruction, register 1 contains the number of bytes that are that the array takes, but one element takes 4 bytes, so I have to divide it by 4 to get the number of elements. Now with this much information, I can branch link to the average function, and after getting that I will be receiving the average in the 0th register, which I will store onto the stack by what? By doing what? This store the value in the 0th register onto the stack by pre-incrementing the stack by 8. And now I would like to load the address of the string into the 0th register. String into the 0th register. For that, first I get the page address, and then, like always, we have to add the page offset, not hash, but apostrophe, not apostrophe. What is it called? At the rate mark. I am live, right? Yup. Ich bin live. Now, yes, after getting the value that I want to ingest into the string and the string itself, I can successfully call printf function. And after that, I have to clear the stack. And how? By adding to the stack pointer 8 and then loading the original values of frame pointer and the linker register onto the stack, and then incrementing the stack by 16, and then I can just return. And before that, I will move into the 0th register value 0, that is the return value for this function. Now I would like to define the label average. Now here at the start of this average function, I can expect that I have in the 0th register the array, the pointer to the array, and in the first register the length for that array. Now I would initialize the third register to have value 0. This will be our counter, and I will post increment this, and now I'll create a loop to which I will keep coming back. And how many times would I like to come there? From, like, if the array has 3 elements, then I would like to go through this loop 3 times to add all the 3 elements. And how would that be? Um, oh, yes, how would that be? Mm, I start with 3, then I subtract 1 at the end of the first loop, then I check if it is 0. It is not, then I am start the loop again, then perform the actions in the loop. At the end, I subtract one more and I see if it is zero. It is not, then I start the loop again and subtract and then check if it is zero or not. So I subtract and save into register 1 the value 1 and then compare the contents of register 1 with 0, and if it is greater than the contents of register 1 are greater than 0, then I loop. Else I just no, not return. I can expect to have in the third register the sum of everything. So I divide and save into the 0th register. I divide the contents of third by shit, I would like to have a length. Shit. So I want to preserve the length. So I will start with 0 and go till it is 3 and move into the third register the content, the length of the array. Wait, I have 0, 1 and I can use the second register, so not I should not be stupid. Yep. So here at the start of the loop, in the second register, I have my what? What do I have? Oh, I have to start with 0. Wait, what am I doing? Yes, correct. And instead of subtracting 1 from our original counter, I will be adding 1 to our counter that is in the second register and then compare its content with the contents of the first register, that is the number of elements in the first register. And if it is less, the counter is less than the number of elements in the array, I start the loop again, and then at the end I can expect to have in the third register the sum of all the elements and divide that sum with the total number of elements in the array and save that division into the 0th register and then return with that value. Now here will come the juice. Here I have to add to the third register the current element of the array that I am on. And what is the current element of the array? I add and save to the third register. Add the contents of third register with the contents of second register and give them a logical shift left of 2, which essentially means multiplying the contents of the second register, which is the offset, by 2. And what do I get? I just get the address. No shit, I need to have the value at that address. Okay, so I can store the address. Wait, what the heck am I doing? I have the address in the 0th register and I need to add that offset. Okay, so let me use the 4th register to store. Uh, I will add, I will store in the 4th register the sum of the 0th register, that is the base address, and this add to the base address the this this is the offset, the base address, this in the 0th register plus the offset I store that address in the fourth register, and then I load in the fourth register whatever uh, the value whose address is at the this register is in the fourth register, and that will be a word that I load because I am store each element takes a word. Hmm, that makes sense. That makes sense. And then I add the contents of the third register, that is the sum till now plus whatever is in the fourth register x4. I add them, and yes, that should do it. That should actually do it. That seems correct enough. So at the end, I expect to see the average for these arrays, for this array. Let's see, there might be a problem because of 32-bit or 64-bit, but let's see. Yeah, there might be, but yeah, I am loading here. I'm loading. I have to load a single byte here. Load into register a byte that is at the address this. That should do it. Yeah, that should do it. Line chapter 5. Yeah. Div. Did you mean sdiv, signed div, unsigned div, or fractive div? Okay, so okay, I seem to be stupid. Okay. First I div here. So this is a sign. This is a the unsigned div, right? And this, where is it? The second div. This is a sign div. This one is signed because the elements in the array can also be negative, and this one is unsigned because it is just the count, the number of elements in an array. I do not expect that to be negative. Nulled operation for instruction. Unsigned div, I cannot give it number 4. Okay, I cannot give it number 4 somehow. Invalid. What is the problem? Recompile. Shit. Um, AArch64 division, aka ARM64. Part 5, multiplication and division. And multiply and add. Where is division? Unsigned div. Okay, I cannot provide an immediate value here. Can I really not provide an immediate value here? Shit. Okay, if that is what you want, let me oblige. Move into the third register, which second register, which I'm not really using for. And then here, use the second register. Expect to see some averagey things. bus error because of stack. Okay, stack is a shitty thing. It seems like I cannot add move a stack by 8 bits. So I have to do 16 here. This is actually the average. No, that just seems like the goddamn sum. Okay. No, this could actually be the average. ChatGPT give reasoning model. Okay, give me the average for these numbers. Analyzing shit. ChatGPT can think longer before responding for better answers to your biggest question. I want to have the average. 106. I think the answer was something like that. 106, 865. 865. God damn it. What is this? Oh, oh, here's the whole code. It is in Python. Sum of the elements and then length of the elements. Okay, question number 11. Write a complete write a complete function in AArch64 assembly that is equivalent to the following C function. Note that A and B must be allocated on the stack and their addresses must be passed to scanf so that it can place their values into memory. Read and add. Read and add does not take anything, it only returns a number. What does it do? It initializes integers, this and this, A and B, and integer called sum. Then it calls scanf to take A from standard input, then B from standard input, then add and return the sum, which I will print from the main function. Vim, we go, and in the end, we have string. Um, the sum is my dick. Okay, we have the sum. Yes, that is all we would need from the dot data section. In the dot text section, I would like to tell that I have something called a function called global, a function on a label which is global. That is, it can be accessed from outside. And here I will have not ASCII but a line at 4 bytes space, and then I will define the main label whose first instruction would be to store the stack pointer and the linker register like the good boys that we are. Mashallah, boys come home. Boys played well. Okay, and then after doing the good boy stuff, what do? We we can just call the function. We do not need anything to pass on to the function. We can just literally call the function, which is going to be scan and sum. And then after that, I would expect to have the sum in the zeroth register, which I will put onto the stack, pass onto the stack. And how would I do that? To do that, do store the contents of the zeroth register onto stack with an in getting 16 bytes of memory on the stack, and then I will load nope, at the address of the page in the zeroth register for string, and then I will add to it the page offset and then branch link to printf. And yes, now I have printed. Now I would like to clean this stack from all the shit that I have given it, like this, and then I will load back the values for the frame pointer and the link register onto the stack, and return with the exit code 0. Move into the 0, space 0. Here I will implement that label, scan and sum. What does it do? The first thing it does is it gets a space on the stack. By what? By mm, move, no, not move, subtract from the stack. Wait, first it should save the link register and everything onto the stack. Should it? Should it not? Should it? Should it not? I am using the stack, but I am not changing the link contents of the link register, so it works. I can just get 16 bytes of storage on the stack by doing this. And now I would like to call printf, but yes, I would also like to have format string as keys over here, which is just %d, and I would like to have its address in the 0th register. Yes, and then pass the address of the free memory location onto the stack to the printf, to the scanf function. Okay, first I load into register 0 the value of the page address for the format string, and then add to the 0th register the page offset. Now I would like to have what? Some space on the stack. Uh, yes, I have the space on the stack. Now I want to have the address from the stack for the number that I want to store there. So for that, I will save in the first register the sum of the stack pointer and 8. This will give me the upper 8 bytes which I got, the upper 8 free bytes that I got on the stack. Now I have that address in first register, but I would like to store that address where? Onto the stack, top of the stack. So store the contents of the first register at the memory location which is at the top of the stack. Then I can call bl scanf, right? Yes, now I would like to have the address back, but I can maybe store this address at this point. I call this function. Is my video okay? Okay, yep, my video is okay. When I call, when I get the address and for the first time, I can store this in the 19th register, x19th, and then get it back later after calling the function. So move in the 0th register the address which I stored in the 19th register before calling scanf, and add and store in the first register. No, nothing. I would like to store the top of the stack, the address of the top of the stack at the top of the stack. That is crazy. Now store the contents of the stack pointer at the top of the stack, which is like some bad things I do not want to say yet. First, I will earn money and then I would start speaking shit. Now, stack. Yes, I can call the scanf now, not scanf, but scan, scanf. Yes. Hmm. Hmm. Makes sense. What do I expect to have now? I expect to have the first number on the lower 8 bytes of the stack and the other number at the upper 8 bytes of the stack, which is okay. Okay, so I get, or now I will get those values. Load in the half of the zeroth register because 32 bits is the length of the number that I am storing. 32 bytes from the stack pointer. That is good. And then load the other 32 bytes in the first register and add an offset of 8 to it to get at the upper place. And now add and add and save to the zeroth register the sum of the first 32 bits and of the zeroth register and the first register, and then I can just return. But before returning, I have to clear the stack pointer by adding to the stack pointer 16. Not like that, that is very stupid. Yes, like that. That works, right? That should work. Then I can clang. Okay, load and stack pointer line 22 and 44. That is both are multipliers of 44. Stack pair, here also load pair, and line 44. Store the contents of the stack at the top of the stack. Yes, that makes sense. What is the error? Invalid operand for instruction. Hmm. Maybe it cannot access stack like that twice. So let me move into the first register, I suppose. The contents of stack pointer, and here store the contents of the first register onto the stack. What do I expect to see? I expect to see them asking me two numbers and then printing the sum. 23, 32, 55. Segmentation fault. That is very tragic. My first segmentation fault, I guess, in assembly language. Okay, here is the place that I am messing up with the stack. I add 16 to the stack before literally I take no safe measures, but it should work. This should work. I subtract 16 from the stack to get 16 new bytes onto the stack. Then I get the address of this page. Maybe something is happening with the 19th register. So I can do this. Load the address again instead of first storing it to the 19th register and then getting it back. I call the first scanf function with having 16 bytes onto the stack, then first getting 16 bytes of memory in the stack, on the stack at the top of the stack, which is actually the bottom of the stack. Then I get the address in the 0th register for the string, format string, and then I add 8 bytes to the stack to get the upper 8 bytes on the stack. and then I store that address at the top of the stack. Then I call the scanf function, and then I load the address again into the 0th register, and this time I store the address of the top of the stack at the top of the stack. And then I call branch again, scanf again, and then I get the numbers that I stored on the stack. First number would be at the top of the stack, the second number would be at the other 8 bytes. Then I add them, and well, I haven't made any change. I changed the way I was getting the address again. Segmentation fault. So what is causing this segmentation fault? What is causing this segmentation fault? Is it these two lines? If it is, let's do this move to the 0th register, this number, and move to the first register, this number. Why they keep asking me? What the heck? What the heck? Why doesn't it end? Why is it not ending? What the heck? 300 lines of code. That is crazy. 300 lines of assembly code is crazy. Okay, why did it keep asking me again and again and again? Scan and sum. Scan and sum with nothing. Hmm. 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 I subtract 16 from the stack. Maybe the problem is from there that I am subtracting 16 from the stack. So the stack pointer contains address of the top of the stack, the byte at the lowest of the stack, which is the top of the stack here. Stack grows downward. Then I'm getting address of the format string in the 0th register, and in the first register I am getting the, like, if the stack is here, then I'm getting the address of the byte here. The upper 8 bytes which have been allocated to me. What is the problem here? I don't see the problem. In the 0th register I have what I want, and in the first register I have what I want. Let me instead of doing this, let me do this. 32 and 16, and yep, here 0 and 0, and here I would do 16, and here I would do 32, and if I were you I would do this here and this here and delete these two, and then try it out again. Segmentation fault. What is causing the segmentation fault? Is it just I store? What am I storing here? onto the stack. Yes, and then I am adding 16 to it. Hmm, in the zero. Oh, this in the zeroth register I have that. I don't think this is the cause of the problem. The main function we can see by commenting this out and saying that we want to move in the zeroth register this some stupid value. Uh, the value is too big for the instruction to store in itself. See, so the problem is not with the main function, is with the scan and some function. Here I am subtracting 32 to get 32 new bytes on the stack. Makes perfect sense. And then I'm getting the address of the format string in the zeroth register, and in the first register I am getting the address of the top of the stack. Not the top of the stack, but the upper 16 bytes of the stack. Mm, but why am I getting segmentation fault here? Store the value of the first register onto the stack. It is not load, right? It is store. Yes, it is store. Load is to get the value from the memory, but store is to store the value in the memory. And then in here, I am loading two values from the memory. Okay, is this the thing that is causing the problem? Comment this out and move these values into these registers. Clang it. It will keep asking me numbers. Shit, this is not making any sense. Why the heck this is happening? What is happening? Okay. Okay. If I comment this out, that is, I am not asking for any values. I'm not loading the values from the stack. Then I am getting error. I think the error has to do something with how I am dealing with the stack. The error is, of course, with something that I am doing with the stack. Now, what is it? That is the problem. What is the thing that I'm messing up with the stack? Where am I messing up with the stack? First, I am here subtracting from the stack, right? I'm subtracting 32 from the stack, and then I'm getting the address of what I want. In the zeroth register, the format is string. The format is string is also perfectly good, right? It has to be %d. Yep, it is %d, and then I have to provide the address to the scan. If it is, yes, scan f, which I have also used in the past to scan values, and I am providing the address at the top of the stack. Wait, maybe instead of this doing like directly this, I can, I should not provide, I should provide this here, maybe, I don't know. And then when getting that value, I can add the offset of 8. Let's see, at least it should not ask for numbers again and again like it is asking right now. That is so stupid. Why is it, why is it asking for numbers again and again like that? Clang it and segmentation fault. But if there is no segment, when I'm not, so the segmentation fault had this add to the stack. That is, op, I go op, right, and that is what I want to do. That is what I should do. That is what any human beings should do. Go up in the stack, which is actually going down, which is going uh, going up in actuality means going down in the stack. So we are going down with in the stack here. What the heck is the problem here? Loading, then branching to printf here, branching to scanf here, scanf there. And I know for a fact that the first argument, the address for the first argument, the string, goes in the 0th register, which I am doing properly, and the memory address goes here at the top of the stack. That is the second argument goes at the top of the stack. Not just this, I have in the past done more complicated things, I believe, with scanf and passing multiple addresses at scanf to scanf, not at. Hmm. 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 Key. And why does it keep calling itself when I am not loading the values? It may be, nah, it is not a scanf calling itself again and again. Why would it call itself again and again? And I am actually stupid. I think I am actually stupid. Here, since I am calling scanf with branch link, that is updating the link register. So when I return here, where the fuck do I go? Right, because the link register contents have been updated. Yeah, shit. So I have to store the contents like this, the link register and the frame pointer here, and then after freeing up all the space, I can get them back by loading the pair of the frame pointer and the stack here. Um, this should work. No error in compilation, and it is asking me for numbers. Okay, that was the error. I was not I was not saving the link register because in the program here, what the heck? No, 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 no. Because here, here I am calling the scanf function with the branch link that is updating the link register. So at this point, if I'm not saving the link register here, then when I call this, my link register gets updated with the value of this instruction. So when the scanf exits, it starts executing from here, and then when it reaches this, the link register gets updated with this value, and then when I do return, when I do return, it gets returned to this address. When I do return, it gets returned to this address. When I do return, it gets returned to this address. Okay, now we have done these. Only two questions are remaining. And can I see the time that I have been streaming on OBS? Does OBS has the times? Shit, frames are dropping. What the heck? Questions are remaining. Okay, it is good. Maybe it is like how many frames have dropped till now. Yes, frame dropped. That is till now. 200 frames have been dropped. So I guess that you guys do not have 203 still frames of me, which is might be sad for you. I don't know what's it, but this is like nothing. So don't be sad. The fractional function, factorial function can be defined as this. Fuck. I wrote factorial function like I remember at some point I wrote factorial function in assembly and I sent it to my friends. The following C program repeatedly reads x from the user and calculates x factorial. Repeatedly reads x from the user and calculates x factorial. It quits when it reads end of file or when the user enters a negative number or something that is not a integer. So what does this do? This is a function that takes a number integer and returns an unsigned long 64-bit unsigned number that is 64 bits. If x is less than 2, return 1 factorial. Like less than 2 is 1, so I return 1 for 1. But if it is not, then return x multiplied by x minus 1 factorial. Yeah, then this is the main body which initializes an integer x and a good value. Okay, and then what does it do? It prints enter x, takes in a good value that is a 32-bit integer, and if good value equal 1, that is if it is 1, then printf that x is not equal to x factorial. X equal to x factorial. This is for factorial. X factorial equal to the long integer if good value is 1. What is good value? What is scanf return? Uh, what is scanf return? Scanf returns. What the heck does scanf return? The scanf return in C. Scanf in C, scanf returns the number of input items successfully matched and assigned. This count does not include fields that were read but not as the fields that were read that were this does not include fields that were read but not assigned. If an input failure occurs before any convention or if the end of the input stream is reached before any convention, conversion is scanf returns the value of end of the file, which is typically defined as -1. A return value of 0 indicates there are no fields. Successfully read two integers. Okay, scanf returns the number of integers that it has read. So if I enter one integer, then it prints the factorial for that integer. But if I do not, and this it keeps doing till I give it one integer. Okay, that is what we want to have. How long is this file at this point? This is 375 lines long. That is not too long. Okay, so first I need to have a format string which will store the first argument for the scanf function, and then I have the string that will print the factorial, which I will pass in as the first number to as the first argument to the printf function, as the first argument to the printf function. So we have %d factorial equal to percent long unsigned and new line. That should do it. And then we have dot text, where I say that there is a label called main which is global, and align it by 2, and here we define main, and here store pair, we like good human beings that we store the frame pointer and the linker register onto the stack by pre-incrementing the stack by 16. What the fuck? By 16. And then what do we do? We first, yes, I would like to make a function which can calculate factorial. Factorial, what does this do? This function expects to have in the 0th register a value. Something. Right? Something. Here it will have a loop inside the function. That is, which is just crazy. Yup, it is. Yup, it is. And before calling the loop, I would like to do this exact same thing here. Copy paste, yes, like any programmer does. And then in the 0th register, I have the values whose factorial I want to have, right? And supposedly it is not 0 or 1, I guess. First, let me compare it. I will first compare, and this will lead it to branching twice. So let me do, in the first register, I will have the answer, which will be initialized at 1, and then I compare the contents of the 0th register with the value 1, and I see branch if 0 is if the contents of the 0th register are less than or equal to 1, then I end. Otherwise, I just I first have to multiply. Yep, I multiply the contents and store them into the first register, the contents of the 0th register and the contents of the first register. Multiply them and store them in the first register. That makes sense. And then decrease the contents of the 0th register by 1. Okay, after subtracting, I branch to the top of the loop, and here I just end. And what does end do? End moves that value, the answer, into the 0th register from the first register, and no, before returning it gets back the frame pointer and the link register from the stack. For that, it does load pair frame pointer and link register from the stack king canute. Okay, and then it returns. So this factorial function, I can expect it to find the factorial. Now here, I would like to start a do while loop. For that, scan and print. What will this do? This will first of all scan and then print. Self-explanatory. So to scan, I would like to have some storage on the stack. So subtract from the stack some value. And what is the value? Subtract from the stack 16. Now I have 16 bytes at the top of the stack. And then yeah, I can get the address of format string here. Now I would also be printing again and again, so it doesn't matter. I will have to get the address again and again. Right. Okay, so getting the address first, I'll get the page address in the 0th register for the format string, and then add to the 0th register the offset for the format string. Now I have the address of the format string in the 0th register, but now I would like to have in the first register the stack pointer, and then store the contents of this first register, that is the top of the stack, at the top of the stack, and then branch link to scanf. Now in the 0th register I have I will compare it with 1, and if it is equal, then I would like to print. Ah, shit, that is just crazy. Okay, now I compare the contents of the 0th register, which is the output, which is the return value of this of scanf. I compare that with 1, and if it is equal, then I branch to print fact. No, so this one doesn't just print it, it only scans. The one that actually prints is this one here, print fact. What does this do? It expects shit, it doesn't expect anything. uh, okay, I will move the return value from the scanf function to the first register, right, just like that, and I will here compare the first register, and I will update the 0th register with the number whose factorial I want to find. And what is the number? The number is stored at the stack, so load the value from the stack into the 0th register from the top of the stack, which at this point, wait, I might be stupid. Subtract, not 6. I will give them the upper 8 bytes of the stack, the upper 8 bytes. Okay, now I store that at the top of the stack, and when I'm getting the value, I also have to add 8 here. Right. So at this point, I have the number whose factorial I want to find in the zeroth register, and then I compare 1, the return value of this scanf function, with 1, and if it is equal, then I go to this function. This function has in the zeroth register the number whose factorial I want to find. So I can just branch link the factorial function, and this returns in the zeroth register the factorial. So I have factorial in the zeroth register, which I can store at the top of the stack as the second argument to the printf. I also need to have the number itself whose factorial I have found. I need to have that number. I cannot lose that because that is that has to be there. I need that number. Ah, fucking hell. Okay, so wait. Since um I'm making a call here. Wait, this is a little bit complicated. Nope, it is not. Since I am making a function call here, that will update the link register. That will actually update the link register. So I should store the link register. Shit. I should store the link register just like that, and call the factorial function. But this has updated the link register. So that is no problem. That is literally no problem. But I would like to okay, in the zeroth register I have the in the zeroth register I have the number whose factorial I want to find, right? And when I am in this function, I have that number in the zeroth register. I can store that number, move that number into a non-volatile register, that is the 19th register, and then call the factorial and have the factorial in the zeroth register, and I can move into the first register the value from the 19th register, which is the number whose factorial we found out, and put both of these at the top of the stack. And what is the order that I want to put them in? I want to subtract from the stack and store at the stack the value 16. Now I have 16 bytes of memory at the stack, at the top of the stack, which is actually the bottom of the stack. This is just the way assembly is. Okay, now I got the value at the stack. I would like to store these values on the stack. So store the contents of the zeroth register and the first register at the top of the stack. Yep. So wait, I can just do this. I pre-increment the stack here. I'm getting out of line here. Thinking of myself as if I can come up with a good solution. Okay. Now I have stored the values that I would like to pass on to the printf, and now I need to get the address of the string. For that, first I will get the address of the page of the string in the zeroth register, and then add to the zeroth register the offset for that string page off, and then just simply call the printf function which at this point where I am at line 45, I would expect it to have printed the values, and then after that I go back to the scanf function to scan the next pair of values, right? But before that, I get that back the values for I reset the stack, right? Add to the stack 16, which I got here. So I pop it off the stack and then return. Just return. Nope. I load back, load pair of the, the frame pointer and the stack pointer from the stack, and then again update the stack by adding 16 to it, post incrementing the stack. Nope, not return, but this function will always branch to scan. This function will always branch to scan. So after this, I will start executing from here, getting the string in the 0th register to pass on to the scanf function, and the address to pass on to this here, and doing all my comparisons here and there. And then if I do not get one here, if I do not get one here, something else I would like to exit the function completely. But before that, I have to fix the things that I have done to the stack, which is, first of all, I will add to the stack pointer 16, the number of bytes I allocated here, and then load the frame pointer and the link register from the stack, and then post increment the stack by 16, and also return. And yep, seems like this should work. This should work. Seems like it. Error, error, error. Okay, only two errors. We got this. B loop, okay, that is typo and invalid operation. Operand for instruction. Uh, this line 44. Store. Okay, store pointer. I have to. I did not use store pair there. Line 44. Okay, here this should be store pair, and where am I using the BL function? What are the places? Branch to the loop. Yep. Now, well, at least it is compiling, and now error, error, error. What is the factorial of 1? That is exactly the factorial of 1. The factorial of 2 is also that. That is shit. I did not expect it would. Okay. Okay, so the factorial is being printed before. Yeah. Of what if minus 1? When should the function exit? When I. When should the function exit? When I do not provide anything. End of line. D. So the print is messing up somewhere. I'm getting the this here. Oh, 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 oh. Okay, is that it? That seems to be it. So the problem here is this. When I'm storing these two here, the first 8 bytes are taken up by this, and the second 8 bytes are taken up by this. But to the printf function, in the string, I am saying this, that the first one is a digit. That is, it takes 4 bytes. So, and the second one is a long unsigned integer. That is, it takes 8 bytes. But the first number I have stored using 8 bytes, and the second number is also stored using 8 bytes. But printf, after seeing the first 4 bytes for this number, it starts looking at for this number. It starts considering the remaining 8 bytes, which is the MSB for the zeroth register and the LSB for the first register as one thing. So that is a mess up. And another thing, that these can be reversed. Now this should work. Factorial of 1 is 1. Factorial of 2 is 2. Factorial of 3 is 6. Factorial of 10. Let's see how long we can go. It is long. So yes, it has started to rewind back. Factorial of, and it is unsigned, therefore it will not. Wait, I am using full 64 bytes, right? So full 64 bits. So the limit should be much more than what I am getting here. Uh, long unsigned, long unsigned, long. What is long? Should it be Excel? What is how to say 64? How to print 64-bit integer in C? Yep. In GCC, yeah. Stack Overflow is down. Or my internet. No, my internet is stuck here. It is right here. LLU. Long. Let's wait. This one, the emoji was moving. Cyberfish. Ah, the emoji is moving. Yay. Wait. LLU. Long unsigned. I don't know. Okay, 56 is 0. That makes sense, I guess. 13, 14, 15. Still going. 16. Stopped. Yeah. Stopped. Okay. Now write this program in AArch64. Okay, I did wrote that program in AArch64. Now this, for large x, for large x, I have a large X. Is someone watching? One person is watching, that is me, and frames are being dropped like crazy. Shit, that is not acceptable. That is literally not acceptable. The way frames are being dropped. Should I decrease the bit rate? It is going touching 6,000, which is quite a bit. 5,000 continuous bit rate, CBR, and the quality is also supposed to be well. Now it seems to be good. Why am I just sitting there and not speaking anything? Okay, that is a stupid version of me just from 2 minutes ago. And the bitrate has fallen and seems to be good. Okay, I am live. The lag is crazy. The lag is literally crazy in YouTube. Yeah, I cannot even close this. Shit, shit, like sheep, the one who goes into the caves, the dungeons, the mines. For large X, the factorial function is slow. Yes, makes sense. However, a lookup table can be added to the factorial dynamic programming function to avoid performing deep recursion X every time. This technique is commonly known as memorization or ta- that is what I have used. Shit, I did not use recursion. I used this thing only. This technique is commonly known as memorization or tabling, but it is sometimes called dynamic programming. The following C implementation of the factorial function uses memorization. Modify your AArch64 assembly program from the previous problem to include memorization. My function does use memorization. Yes, my function does use memorization. It is not using recursion, it is using a loop which multiplies. So, yeah, yeah. So essentially, we have completed this chapter number 5. We can move on to abstract data types. But before we do that, my water has not broken but finished. So I will first get my water and is it still dropping up? The frames are not dropping, so that is cool. Abstract data types. Let's create a target. An abstract data types. How long is this chapter? And whatever 168. I will get back to page number 168 after see this. Okay, abstract data types, ADT, word frequency counts. This is this word frequency counts is that is the motherfucker in this chapter. But ADT is in assembly language. I guess that we can complete. It is just 3 pages long. So, and how long have I been streaming? Just we have 1 hour. So I guess we can complete this half, right? Ethic, ethics case study. Shit. Are they telling us to not hack things? Hey, what was the number? 168. Abstract data types. Okay, we will come back to this. Let me just fill my water bottle and I will come back. Bye. You guys can listen to something, you can watch something. Yeah, Jordan Peterson daily motivation. But that might get me copyrighted, so we'll leave it at this. You can watch. Yeah, let me just go and do my thing. Seems like I'm back. And yep, I am back. Abstract data types. Have we seen this word before? I guess we have, but I cannot remember. An abstract data type is ADT, is composed of data and the operations that work on that data. That is an object. The abstract data type is one of the cornerstones of structured programming. Proper use of ADTs has many benefits. Most importantly, abstract data types hiding help to support information hiding. An abstract data type. The data type has been abstracted, all the implementation details and everything. ADT hides information by encapsulating the information into a module or other construct and providing a well-defined interface. The interface typically consists of the names of data types provided by the ADT and a set of subroutine definitions or function prototypes for operating on the data types. The implementation of the ADT is hidden from the client code that uses the ADT. That makes sense. A common use of information hiding is to hide the physical storage layout for data, is to hide the physical storage layout for the data that so that if it is changed, the change is restricted to a small subset of the total program. For example, if a three-dimensional point XYZ is represented in a program with three floating point. For example, if a three-dimensional point XYZ is represented in a program with three floating point scalar variables and later the representation is changed to a single array variable of size 3, a module designed with information hiding in mind would protect the remainder of the program from such a change. Okay, a common use of information hiding is to hide the physical storage layout for data so that if it is changed, the physical storage layout of the data, if it is changed, the change is restricted to a small subset of the total program. Okay, for example, if a three-dimensional point XYZ is represented in a program with three floating point scalar variables and later the representation is changed to a single array variable of size 3, a module designed with information hiding in mind would protect the remainder of the program from such a change. Okay, I guess that makes sense. When I change the data on which operations are being performed, then only the data on which the operations are being performed is changed, and the operations themselves do not change. They remain what they are. Information hiding reduces software development risk by shifting the code's dependency on an uncertain implementation onto a well-defined interface. Clients of the interface perform operations purely through the interface, which does not change. If the implementation changes, the client code does not have to change. Makes sense. Only the that is called refactoring. Encapsulating software and data structures behind an interface allow the construction of objects that mimic the behavior and interactions of objects in the real world. For example, a simple digital alarm clock is a real world object that most people can use and understand. They can understand what the alarm clock does and how to use it through the provided interface buttons and display without having to understand every part inside of the clock. If the internal circuitry of the clock were to be replaced with a different implementation, people could continue to use it the same way and provided that the interface did not change. Makes sense. ADT is in assembly language. As with all other structured programming concepts, ADTs can be implemented in assembly language. All is other structured programming concepts. In fact, most high-level compilers convert structured programming code into assembly during compilation. All that is required is that the programmer define the data structure. Yeah. Wait. As with the okay, in fact, most high-level compilers convert structured programming code into assembly during compilation. That makes sense. All that is required is that the programmer define the data structure and the set of operations that can be used on the data. Listing 6.1 gives an example of an ADT interface in C. The type image is not fully defined in the interface. This prevents client software from accessing the internal structure of the data type. Definition of an abstract data type in C header file. If not define H image, then define image H. Okay, that is if image H is not a data variable in the function that this file is inputted in, then define it, right? And what does it do? This does this include stdio, then type def changed the type of unsigned integer character 256 unsigned integer, that is just 256 values, 255 from 0 to 255 to p value, pixel value, structure image struct. What is image struct? There is a structure called image struct, and I change type of that image struct structure to image. Okay, and then I create a pointer to a image which allocates it is a pointer to a function which, what the heck is happening here? Void free image, it takes in an type image type is this image structure, and it a pointer to that, and it frees the image. Whoa. This is a function declaration that there is a function called allocate image which returns a pointer to an image. Okay, then we have integer read image, then we have, oh, this is just the goddamn header file. Yes, why am I being stupid? This is just the header file. Okay, int read image. There is a function called read image which takes in a pointer to a file and takes in a pointer to a image, and then there is a write file, a write image which takes in a pointer to a file and a pointer to an image, and then returns an integer, both of them. And there is a set pixel RGB which first takes in a pointer to an image, then number of rows, columns, pixel value, RGB. It sets a pixel, and set gray. Okay, that is, it takes a image pointer and a row and a column and a pval value. So the whole thing becomes same color, I guess. The whole thing becomes the same color. Okay, and then this is get RGB, and this gives a pixel for a specific pixel, the pixel values for a specific pixel, and this returns a pixel values for, and this is just the header file. Okay, gives an example of an ADT interface in C. The type image is not fully defined in the interface. This prevents client software from accessing the internal structure of the image data. Therefore, programmers using the ADT can modify images only by using the provided functions. Other structured programming and object-oriented programming languages such as C++ Java, Pascal, and Modular 2 is a programming language. It seems provide similar protection for data structure so that the client code can access the data structure only through the provided interface. Note that only the p-value definition is exposed, indicating to client programs that the red, green, and blue components of a pixel must be number between 0 to 255. And C, as with other structured programming languages, the implementation of the subroutines can also be hidden by placing them in a separate compilation modules. Them in separate compilation modules on only the ADT implementation code will have access to the internal structure of the image data type. Makes sense. And then assembly language does not have the ability to define a data structure as such. Assembly language does not have the ability to define a data structure as such, but it does provide the mechanisms needed to specify the location of each field with respect to the beginning of a structure of a data structure as well as the overall size of the data structure. With a little tough and effort, it is possible to implement ADTs in assembly language. I guess that would be by allocating space on the data section and having some fixed standards, fixed location, and in that specific amount of memory space, we would have specific offsets to store different data and functions. Hmm, that makes sense, I guess. But that does not actually make sense because how can I store instructions in the data section, right? But I can store a address of the instructions that are in the text section. But can I store those addresses in the data section? Nah, I don't think so. Yes, we can. We actually can. Get some memory, but do not initialize it. Just declare it in the data section, and then in the text section, I can, during the implementation of the code, when the code runs, I can update that memory cell with the address of the instructions. Now, uh, it is possible to implement ADTs in assembly language. We go, let's go. Wait, oh, shit, this is so bad. Can you guys not see? Shit. Mac OS screen capture, display capture, yes, yes. But why can't you guys see um the other things that I'm doing? Ah, shit. Why is this display capture stuck? Shit. And how long has this been stuck? It, problem after problem, I guess. Yes, I want to remove it. And then add screen capture. Shit. Yep. That is what I would like to capture. Capture. You guys can see my screen, it seems. Oh wait, I can just directly do this. Um, transform fit to screen. Yep. And now you can see what I see. Yeah, now you can see what I see. Oh, maybe I can hide from you my OBS, but that is mm, close sourced. That would mean the close sourced things, but we are open source. So. I will not. Definition of image structure is hidden in a separate header file and not available to the client code that uses the ADT. Type def struct pixel. This is a pixel which have pval things, arch and v three things which are pval, and here we have structure image struct. Image has a pointer to pixel, array of pixel, and number of rows and number of columns. Definition of ADT in assembly. What is EQU? EQU means that this thing, whenever I use this label, I would get this. And whenever I use this, I would get this. Whenever this. Size of the pixel data structure, offset of the blue, offset of green, offset of red, rows, columns, pixels, and size. Definition of pixel and image data structures. Offset, offset, offset. These three are offsets. Rows offset, column offset, and inside those rows and columns, this is the offset for pixel. If I want to skip a pixel in a specific row or in a specific column, and if I want to skip the size of image data structure. Okay, images, these, a pointer, rows and columns. Okay. Listing 6.2 shows the private implementation of the image data type, which is included by the C files, which implement the image abstract data type. A pixel is defined as a C structure with 1 byte each for the red, blue, and green color components. Since the largest item in the struct is a byte, I am totally lost. A pixel is defined as a C structure with 1 byte each for red, blue, and green. A pixel is a definition. C, which has three things: red, green, and blue variables, which take 1 byte each. Since the largest item in the structure is a byte, the C compiler will create a structure that is exactly 3 bytes long without any extra bytes for alignment. The image structure contains three integer values. And now the image structure contains three integer values. So it will occupy 12 bytes because one integer value contain stores 4 bytes, uses 1 byte, 4 bytes to be stored. One integer takes up 4 bytes. Now, listing 6.3 shows how the data structure from the previous listing can be defined in assembly language. With those definitions, any of the functions declared in listing 6.1 can be written in assembly language. Okay, word frequency counts. Word frequency count. Counting the frequency of words in written text has several uses. Counting the frequency of words in written text has several uses. That is crazy idea. In digital forensics, it can be used to provide evidence as to the author of written communications. Okay, different people have different vocabularies and use words with different frequency. Word counts can also be used to classify documents by type. Scientific articles from different fields contain word specific to the field, and historical novels will differ from Western novels in word frequency. You're bad. And listing 6.4 shows the main function for a simple C program, which reads a text file and creates a list of all the words contained in a file. along with their frequency of occurrence. The program has been divided into two parts, the main program and an ADT. The ADT is used to keep track the words and their frequencies and to permit a table of frequencies, including a lot of things actually. libc type, studio, studio, Vlad, Vlad. Okay, remove punctuation copies the input to a new string but omits any punctuation character. Okay, remove punctuation is a function. Okay, this is a C whole program. And this function gives back a string and takes in a string. And what does these do? Remove punctuation copies a string but to a new string, copies the input to a new string but omits any punctuation characters. I get a new pointer to a character. There is I get a new space which from malloc I get first I get the length of words, number of words in the string that I got. Then I add one to it, maybe to add at the end the null string, and then I get a void pointer from the malloc function. I typecast that void pointer into a character pointer and I store it in this new word. Then I store the new word into Kurds, Kurdistan, Kurdistan, yeah, Kurdistan. That in Iran, Iraq, Syria, a little bit in no, Iran, Iraq, yep, also in Iraq, Syria, little bit in Azerbaijan and maybe in Armenia. Yeah, Armenia and Azerbaijan are at war now, and I get it is current dust destination, current destination, and current source. Okay, current destination and current source. These are the ones that will be moving forward by adding one to them. While current source is not equal to zero. Okay, so it will start from why would current? Okay, let's see. If now in the while I do this, if string character of any of these types is at this location. Okay, so stir chr is it like compare cm string compare? So if any of these characters are at these, I will get true. But if it is null, that means current character is not a punctuation. Then I do the current destination will store to lower the current source. The character add the current source and current destination will be updated by one, and current source will be updated by one every time. And at the end, why would it ever current source? Why would the current source ever become zero? Ah, zero because zero is at the end null string, right? It is null terminated, so zero is at the last character in the string. Then move the make the current destination zero because you want to make it null terminated, and then I return the new word. So this function takes in a string and removes the characters, removes punctuations and special symbols from the string and returns a new string which is stored at a new location in the memory. The main function reads spaces, separated words from standard in, removes punctuation, and generates a word frequency list. Let's see. Max word length is 1024. That is the size. 1 byte can store 256. 2 bytes can store 256 into 256. What is 256 into 256? Well, it is 256 into 256, right? 65,000. Yep, it is 256 into 256. So this is much less. Max word length is max word length. Word length, a single word. Now, character pointer to the next. I initialize two things, a clean word and next word string. Word list is a pointer. Wait, what the heck is word list? I initialize a list which has word list type. What is word list type? Is it from any of this? Yeah, it is from list. Word list. Probably from there. Then I and then I make the next word is size of char. That is 1 byte multiplied by max word length. So next word has a pointer to a space which is 1024 bytes long. Then list is WL word list alloc, which is also a function I would suppose comes from one of these libraries. Then we have scan, while scanf next word is not equal to 1. While the input value of scanf is 1. And what is next word? Next word is the place where the next word goes. Now, till I am getting a 1, what do I do? Clean word equal to remove punctuation. I remove punctuation from the clean word, which at this point is nothing. And then if stir length of the clean word greater than 0, then I WL increment list with the clean word and then free the clean word somehow. What the fuck is this? This is not making sense, but I'm trying to count words here. Okay. The interface of ADT is shown in figure 6.5. There are several ways the ADT could be implemented. 6.5. Ah, this function uses an ADT. So that is why I am facing problem to understand. I do not understand the interface for the ADT. The ADT is the list thing. And there are several ways that the ADT could be implemented. Note that the interface given in the header file does not show the internal fields of the word list data type. Thus, any file which includes this header are allowed to declare pointers to word list data type. Wait a minute. What do these stuff mean? I think I will have to. Nope, there is no lag there. I think I will have to cut short today. I'm being a pussy right now. Oh shit, it is just code on code on code on code. That is crazy. And I guess there is the explanation for these code in what the heck in the coming things. Better performance. Okay, this I have to think about this as it is interesting. I have to tell myself that This is interesting, and that is the best way that I will get my mind working towards understanding this and not just trying to complete this. And as I said, we have to, quality is our main focus. We have to focus on quality. Quality is the main thing that for which we will not sacrifice other things. Quality is the thing for which we can sacrifice our time and I don't know other things. So we have to understand these properly. We do not want to come back. Well, we can come back if that is what it takes, but if by focusing we can understand what we are trying to understand here in just one read by giving a little bit of time to it, then it is very, very worthwhile to understand it in the first go. So what are we going to try to do? We have to look at this word frequency counts from a fresh mind, right? Because we are for the first half we were giving out information using the things that we already know here, but then we started reading at about 30 minutes ago, right? 30 minutes ago. That is taking in information, and you cannot take a lot of information in. But I understand all this. We understand all this. What are abstract data types? Data types which what are abstract data types? Abstract data types are data types which give the client, the person using those abstract data types, an interface through which they can access the data that is in that data type and through which they can get they can perform functions on those data. So an abstract data type consists of some data and some procedures that can be performed on that data. And the client, the person using that abstract data type, does not has to think about the inner implementations, the inner wirings of that abstract data types. They only have to know the interface through which they can access the data and the procedures that are to be performed on that data. That is abstract data types. And we understand that. We get them through header file. And what do these header files do? These header files let us use those abstract data types inside our program when we do not have the definition for those abstract data types. But the thing is that how do we get the actual code for those data types in our finally compiled file? We get that from the linker. When our file has been compiled into assembly and after that it has gone through the assembler and we have an object file which has references inside of it to those to the abstract data type code, the code that we have imported into our file, then the linker sees those references and it links our code with the code that we require from outside and links all them together. And we have a final compiled file which works and has all the code that is required. So linker is a good thing. And bye.